Good afternoon, ladies and gentlemen. Thank you for coming back from the lunch break. I will try to do my best to keep you awakened, or at least to wake you up at the end of my presentation. It's a great honor for me to be here on this BIM conference, where I get the chance to present our firm's first experiences and expectations about the very first project that we have been working on in a BIM manner. First of all, let me introduce myself. I am David Petri, and I am working as an architect for more than 10 years in a Hungary-based architectural and engineering firm called KÖZTI. KÖZTI is one of the oldest and one of the biggest architectural design firms in Hungary. Last year it celebrated its 66th birthday. Earlier, I have been working for 3 years in the IT sector as a software developer, and in the last 3 years, I also work as a CAD and a BIM manager, which directly led me to this presentation. So in this short, let's say 35 minutes of presentation, I would like to talk about BIM as a concept and how Open BIM can revolutionize the workflow among architects, engineers, the client, and other stakeholders. I am going to show our first BIM-based project, the refurbishment project of the Puskás Ferenc Stadium, the time and task that we spent on the implementation, our final expectations, the problems and challenges that we have been facing, and of course the solutions that we have reached. I really don't want to bore you with the architectural drawings like floor plans, sections, elevations, and so on. I simply would like to show you how we did it, what kind of BIM aspects we used, and that I'm convinced that we have made the right decision by using BIM in our project. Shortly, I would like to summarize the past and present of the stadium to show how important it is for us and why is it a great honor to work on such a tremendous and gigantic project like that, especially in our firm, as this project has been one of the first one in our company's life about 60 years ago. On one hand, it's a historical monument with its suburban environment, and on the other hand, it is a totally 21st century venue which used to be and will be the home of lots of important events, both cultural and sport ones. The first time when the idea came up about the need of an Olympic stadium in Budapest was in 1895. At the end of the design tender, a Hungarian architect called Dávid Károly has been chosen to draw the final concept of the stadium. Earlier, he was working in Le Corbusier's office, which explains the basic structure of the stadium. Finally, in 1948, the construction began, and with lots of afterworks, redrawings, and modifications, it was built and opened on the 20th of August in 1953 under the name People's Stadium. That stadium was a nearly 78,000-seated sport and hospitality facility, plus since then it is the home arena of the Hungarian national football team. Later, in 2002, the stadium was renamed after the most famous Hungarian football player, Ferenc Puskás, who was the captain of the legendary Golden Team. But in that time, so in 2002, there has been made no change on the building at all. In 2013, our company, KÖZTI, has been invited to participate in a huge design tender about the stadium. It was launched as a complex project, plus the surroundings. While we were designing the new stadium, we found it important to use original characteristic elements of the old arena, searching for some balance between old and new. During the design, another key aspect was that we wanted to keep that three-pointed axis of the stadium, the dromos, and the Poplászló and the Budapest Sports Arena. Dromos between the two buildings is a recreational sports park surrounded by statues from the middle of the last century, while Budapest Sports Arena is a 12,000 seated multifunctional indoor venue. And I also have to mention that it's also designed by György Kardelli, who is the lead architect of the new stadium as well. As I said, it's a refurbishment project, which means that there are existing and remaining parts from the old arena, so we needed to visualize them in our BIM model. According to the dimensions of the project, it was nearly impossible to survey the building in a traditional way, so we needed to find a more efficient, a more precise and a quicker solution. Soon we found a group of specialists who used 3D laser scan that allows us to integrate 3D points and survey data to extract measurements, generate deliverables and utilize inside our software. What now you can see on the screen is only a small slice of the stadium, as the whole database is over 4 terabytes big, so it's not easy to handle. The process of capturing an accurate 3D point cloud via laser survey is not as easy as it seems. Meanwhile, another hard task lies in taking this 3D point cloud as a reference and to build a 3D model from that, as the model is what is missing from a point cloud. In the end, this became not only the base of our BIM model, but we also have been able to generate the demolition plans as a part of the building permit and to measure the demolished quantities as well. We are planning to use this technology during the construction for coordination and to update our as-built BIM model before the operation and maintenance phases. I think I will skip the rest of the video, but it's pretty easy to find it on YouTube. So our goal was to come up with a design that meets the expectations of a 21st century facility that is equipped for several in- and outdoor occasions. The new Puskás Ferenc Stadium has to fulfill all the Hungarian national and the lots of international requirements, such as the FIFA, the Green Guide, which is the Guide to Safety of Sport Grounds, or the UFA 2020. The stadium is also expected to award the 5-star rating, which means the premium category among the stadiums. The construction will start in the beginning of next year and has to be finished by 2019. The timely completion is highly important because Budapest and this stadium has been appointed to host 3 group games and 1 last 16 match on the 2020 European Football Championship that is organized by the UFA. I am pretty sure that you can imagine the complexity and the magnitude of the building. On this 3-dimensional section drawing, you can see the basic structure of the stadium with its 3 tiers and their capacity, the all-round VIP and VIP box level between the middle and the upper tiers. Or the stadium contains a police department and the sports museum as well, which is one of the inherited parts from the old stadium. The net floor area is over 140,000 square meters. The highest point of the roof is more than 54 meters from the field. The stadium is more than 316 meters long and 260 meters wide. So thanks to the implementation of BIM, we have been able to handle such a gigantic project properly. The tender curriculum mentioned that the construction plan of the stadium has to be delivered in BIM. And that was the point when we needed to take one step back and ask the question, what is BIM? It was new to us, as it was new to almost every architect in Hungary back in 2013. We spent around 2 months at the beginning to find the best BIM solution software-wise. As I said, we had no clue about BIM and its relations with our softwares. We didn't want to reinvent the wheel, and we didn't have time to waste. So we decided that we are going to ask our software developers, like Graphisoft, as we have been using their software ArchiCAD since we changed from the traditional paper-based working method about 25 years ago. They came to our office, and we started a pretty detailed discussion about the topic, about our possibilities, about our, and of course, our clients' needs. They highlighted that one of the most important tasks during a BIM-based project is the collaboration, the communication, and the data management between the different participants like the client, the other designers, or even the contractor. They helped us a lot as they offered full assistance in the world of Open BIM workflow, IFC file sharing, and to setting up our software knowledge on the level of BIM. Soon, we came up with a workflow together where we decided that we are going to focus on clash detection and quantity takeoff for the first time, and then we will still have the chance to go step by step and see where the life takes us. At KÖZTI, in our company, the software usage was already based on three-dimensional drawings, but we were using it most frequently for scheme conception design, and in the later phases like pre-construction documentation, we stepped back to the traditional document-based working method. During this project, we explored further opportunities how to best leverage our BIM model. For example, it was used for 3D renders and promotional videos. It simulated the camera positions or the movement of the spider cam. Lighting, sun and wind tunnel analysis can be run by that model. So just a long story short, after the first wind tunnel analysis, we have been facing the fact that during a big storm, the Doppler effect could cause serious damages in our structure, but not in the way that it collapses, but the wind would tear off the whole construction. So as a quick solution, we decided to put several tons of weight on it. Of course, later we modified our structure and we didn't need to use that 10 tons of waste material anymore. But the power of having a BIM model doesn't just lie in the benefits of a 3D model, but also in the information that is generated by that model, such as the product quantities or area takeoffs. In addition, the model can be further enhanced by adding products, specific data to the model components or objects that can be extracted in line with the BIM process. If we do so, further possibilities appear like the usage of BIMX, escape route simulation, or we can make different studies, for example, about the different shapes of the ball. But I would like to show you some of these. When we stepped into the phase of detailing our final concept of the stand, we evaluated our model with a group of specialists. They were running a bunch of simulations throughout the design period, like this video on the screen is the escape route simulation made in Pathfinder. I think the goal is clear. All the visitors, including the VIP, the media, and the handicap fans as well, must reach the exit door or outside elevators within 8 minutes. In this case, the parametric objects are the people. They have to be programmed about their route, their speed, and they have to act like in real life. So, for example, the handicap fans are not using the stairs, obviously. In the same manner, different evacuation simulations has to be run for different occasions, like concerts, conferences, or for different football games. So I would like to say some words about repetitive tasks and workflow optimization. Probably one of the most important steps of a stadium design is to define the basic geometry of the tiers. First, we have to define the shape of the bowl according to the different national and international standards. And after that, we have to assess and locate every seat on the stand. Thanks to that new live connection between rhinoceros, grasshopper, and Archicad, it's not a hard task. To locate all the 67 seats on the bowl earlier took more than 2.5 days for one of my colleagues, but with this new algorithmic aided design, it's not more than a few minutes. Once we have the right sequence or algorithm in grasshopper, looks like this in rhinoceros, appears as a native BIM object in Archicad that can be fine-tuned or modified in grasshopper or in Archicad as well. Necessarily, we had to create several sequences to be able to investigate different forms and distributions. Still in connection with the bowl, we have been collaborating with the UFA. An entire study has been made by Fenwick and Iribarren architects about the different shapes of the bowl. For them, we transferred IFC files that containing the most important data about the seats and its relation with the football field. What you can see on the screen is the analysis of our final bowl shape of different aspects. On the diagrams, the areas that are highlighted with blue are the most optimal. So for example, what you can see on the diagram named distance is the determination of the most optimal and maximum value from the center of the field. FIFA and UFA has got suggestions and regulations about the visibility of the seat rows above each other. Probably this is one of the most important, so they call it C value. The seat location chart is based on the determination of the main seat, the VIP and press sectors, and the most valuable areas are on the longer parallel side of the field, as you can see on this chart. So the final chart demonstrates the summary of all the related analysis. They called it phi factor, where this stadium or this bowl attained almost 95%, which is more than optimal for a stadium bowl compared with several other stadiums or bowls in Europe. We also used our BIM model to create stakeholder-friendly graphical models. These are very useful for communicating with people who cannot easily read 2D drawings and enables the client to make informed decisions at an early phase in the design process. So one of the most helpful applications was the 2016 Erhetizer A+ award winner, BIMX and BIMX Pro from Graphisoft. It's really an easy process to extract from Archicad, and we can open it in BIMX. We used it for edge, surface and plan control within the office, and for presentation to the client to keep him up to date week by week. We were able to update his files by the cloud, so he also had the chance to follow the changes on any mobile device before any face-to-face meeting, and to explore the building just like in a video game. Besides the visual appearance of the elements, there are lots of additional information possibilities in the BIMX model. For example, in a hypermodel, we can connect the views like floor plans, sections, elevations, lists, tabulations, and so on. Or we can visualize any property of the element. Abraham Lincoln said that give me 6 hours to chop down a tree and I will spend the first 4 sharpening the axe. So this is what we didn't have time for. We didn't have the possibility to prepare for this project, but to offer the best BIM solution, we needed to write our own big BIM handbook describing the whole BIM workflow, rules and requirements. The handbook lists all the stakeholders and their job requirements, such as for the CAD manager, the BIM manager, or the design controller. It also includes the data management, the required standards like uniformity level or level of detail in each design phase, and of course the time schedule for the whole BIM workflow. Just to mention, all the designers, like engineers, have their own behavior and model building method, so we needed to write a specification for the modeling process as well. We had to set up project-based files that consists of the most common settings like location, orientation, grids and levels. Here you can see the communication between the different software. Naturally, we prefer the native file connection, but in most cases we had to use the IFC file format. Each co-designer needs distinct information from our model, and according to that, we had to export several pre-filtered IFC models. So, for example, two for the structure engineers separated the prefabricated and the conventional elements. For the MEP designers, we had to split our model into several parts because some of their software hasn't been able to import it at once. And of course, several other for other BIM aspects like clash detection or quantity takeoff. The third thing that we realized that our communication has changed almost immediately. We started to share our IFC files with each other instead of 2D and verbal communications. As we merged our models, lots of problems appeared in front of our eyes with offering an option to handle immediately. For example, the void and access information are neither respected for further usage. On the screen, it is a small part of the building. It's a mechanics of a platform elevator that we received from one of our co-designers. It's not more than 50 square meters, but contains more than 3 million polygons that we don't want to merge it with our model unless we want to make beautiful pictures from the mechanical areas. But when the workflow is well set and the model is on optimal level of detail or development, the co-designers are able to use each other's model. So thanks to that change in our data management, the architects were able to use the structure engineer's metal model of the roof that was created in Stakeholder. In ArchiCAD, so in the architect software, it would have been pretty difficult to create the same, but it was easier to merge it with the architect's model with the same parameters and with the same geometry. During the design period, we have been following the reference model principle, where the designers are responsible for only their own model parts and not allowed to modify or delete any other elements. As mentioned, we were focusing on clash detection and quantity takeoff, so I would like to say some words about them as well. For the clash detection, we use the Tekla BIM site application because on one hand it's accessible, usable, reads IFC file format perfectly, and I also have to mention that it is a free application, so all the co-designers were able to use it. Here you can see some snapshots from the clashes. The clash detection was executed in a matrix-based system, which means that we were comparing all the stakeholders model with each other repetitively. At the beginning, we have been just testing our models, and we had a couple of 10,000s of overlaying objects. We figured out that with more precise requirements, we could reduce those overlaps, and we ended up with a few amount of clashes, which is a great result compared with the first attempt, of course. For the communication and documentation of the clashes, the BCF, the BIM collaboration format, was used for each designer. All these data were stored in a central server to be able to share the required files with everyone who had the rights, of course. The usage of BCF indicates the reduce of the communication file sizes, and it's already implemented in most of our used BIM software or BIM applications. We generated a bunch of lists, accounts, and tabulations from our native files during the design phase, like gross and net floor area, buffet counter lengths, and so on. But the final quantity takeoff has been made in two different ways, just because we wanted to compare the two results with each other. The first one was the traditional paper-based working method, and the second one was with the Vico Office from Trimble. This second solution handles IFC file format perfectly, not to mention the native ArchiCAD files. So our job as architects was pretty easy. We collected all the relevant IFC files in ArchiCAD, and we created a native file connection between the two different software. These are the sheets where we collected all the information and quantities detailed with areas, used material, structures, and so on. We truly believe that with this solution we saved lots of time and money, of course. Well, I already mentioned some advantages and disadvantages of using a BIM model for the first time, but on this slide I collected some more. Using BIM, we can visualize a completed building and all its components even before the construction begins. BIM helps us to see potential problem areas and to fix them before the error is committed in the physical world. This reduces the need of costly rework and revisions. It is really great that we can analyze and simulate every aspect early in the design phase, and the way how it reminds us to evaluate, store data, and manage all the information to improve the collaboration throughout the project. But unfortunately, the right side cannot stay blank. Most of our problems came from the lack of Hungarian national BIM standards. There is always a possibility that some of our partners or subcontractors may not use BIM or may not even be able to use our model. Different software are on a different stage in BIM and IFC implementation that could cause serious problems during the import and export process. The relative newness of BIM means that there are a limited number of experts working on the field. This also requires an additional investment in training and education. We know that there are lots of further possibilities behind BIM throughout the whole life cycle of the project, like construction simulation and organization or facility management. But with this project, we got so far. But some of these stages are still ahead of us, so we can use our knowledge in the future. As in this project, the board took the decision to put focus on BIM as an important technology for business development in the future. And according to that, Several further projects has already started, and some of them are already finished in our company. So, in my mind, building information modeling is a flow, a method that can revolutionize the whole construction industry with its standardization and organization of all the tasks and activities within the design, the tender, the construction and operational phases. Its main purpose is to give an overall solution to the challenges of our industry, such as the CO2 emission or waste material or even the decision making, I think. At this moment, the construction site looks like this from the air. So I really appreciate your time and thank you for your attention.